Greetings everyone, and hope you're doing well these days. This talk is to be a quick overview of Agilent's triple quadruple LCMS portfolio. As the product manager for this portfolio, I'd like to show you some of my favorite highlights and things I'd like to point out. Although Agilent has been involved in the mass spectrometry field for a long time, in regards to GCMS, you'd be surprised to find out that our first triple quadruple LCMS launch was in 2006 with the G6410. This was then followed up in the preceding years with the launch of other models within that decade, such as the 6420, which is not shown, but the 6430 and the 6460. A major breakthrough was made at the start of the decade by adding an innovative new component, which is the dual stacked ring ion funnel. And this feature dramatically pushed instrument detection limits lower and lower. Additionally, instead of a linear design, the 90-degree turn in the ion optics rail was included as a way to reduce noise from the fragmentation process. As we move into the 2010s, two related models to the 6490 were launched, expanding on its capability, which is the 6495A with an extended mass range, and also by creating a version of this instrument without an eye funnel, resulting in an incredible workhorse instrument we call the 6470A, many of which are still used today. In addition to the launch of a 6495B model, not shown but launched in 2017, 2017 and 2018 brought along a new era of mass spectrometer instrumentation with the triple quadruple LCMS. This was a disruptively miniaturized platform with onboard instrument intelligence and diagnostics. And based on the hardware inside, we were able to retain the performance of the 6460 within this box. Last year at ASMS, we launched the 6495C with a completely redesigned eye funnel, drastically improving measurement precision and performance for methods containing hundreds of MRMs within the method. Additionally, we've added VacShield, as it was a popular feature from Ultivo that allowed users to carry out maintenance quickly and easily. Lastly, this year at ASMS 2020, for the ASMS 2020 Reboot event, we're launching an updated version of the highly popular workhorse instrument, the 6470B. This retains many of the performance characteristics of the 6470A, but updated for today's problems with the addition of VacShield. So as we move along into the future, ultimately our aim is to enable our users to do good science, driving us to develop new features, technologies, and workflows to keep up with customers' ever-evolving needs. So before I go over the current triple quadruple LCMS portfolio and hardware details, I'm happy to announce that for the ASMS 2020 Reboot, we're launching a new instrument called the 6470B triple quadruple LCMS system. The 6470B triple quadruple LCMS is the latest version of our trusted workhorse on the 6470 platform. Leveraging much of the technology that made this platform successful, you can expect the 6470B to be just as trusted, rugged, and versatile, with the added enhancement of VacShield to maximize instrument uptime and improve ease of maintenance. With that, Agilent's triple quadruple LCMS portfolio contains only three base products. The first product is the Ultivo, which was designed to be a routine workhorse instrument, focusing on ease of use, instrument intelligence, and serviceability, in addition to its most distinguishing feature, its size and form factor. Next up is the 6495C triple quadruple LCMS, our ultra-high performance instrument built to tackle the most demanding routine and research applications. Each technological component has been built to extract the greatest number of ions for advanced applications without complicating the instrument control. This allows researchers to focus on scientific inquiries rather than instrumentation problems. And last but definitely not least, sandwiched between the two models is the 6470 triple quadruple LCMS, our most popular LCMS triple quadruple to date, as it provides the ruggedness, robustness, and ease of use from the Ultivo while maintaining many of the research-enabled characteristics of the 6495C. Each instrument was built to focus on solving different aspects of customer problems while maintaining consistency and cohesiveness throughout. When jumping from instrument to instrument within our portfolio, we've put a lot of effort so users can feel confident that they know how to run each instrument. They're operating with the same familiarity, yet there's a distinct and incomparable uniqueness each model provides. An important and distinguishing feature of Agilent's triple quadruple LCMS portfolio is the fact that all three instruments in our current lineup are VacShield enabled. This unified feature allows users to perform common, usage-based ion injector capillary maintenance quickly and efficiently with minimal downtime. This feature works by allowing the user to remove the ion injector capillary without venting the system. As the capillary is drawn out, a sealing mechanism is automatically triggered, maintaining the instrument's optimal high vac pressure. And what's unique about this mechanism is the introduction of an intentional leak as if the capillary were in place. This design prevents backflushing of oil and contaminants, prevents turbulent gas events from influencing the instrument's equilibrated temperatures. To really point out the implications of this feature, users who implement ion injector capillary cleaning in their routine maintenance often expect to spend about 6 hours or more to do so. This is because they normally have to allow the instrument to cool down, properly break vacuum, carry out their maintenance, then re-equilibrate the system again before carrying out a new check tune or auto tune. Instead, users can simply slide out the ion injector capillary, do their required maintenance, then check tune or auto tune immediately after. This takes about 30 minutes to an hour, and sometimes even faster with Ultivo. And since users no longer have to wait a number of hours to pump down and re-equilibrate the system, they can expect to be done in a very short amount of time. For a little bit of history, VacShield was first pioneered on Ultivo, added in 2019 to the 6495C, and now in 2020 with the launch of the 6470B. Another common feature shared throughout the triple quadruple LCMS portfolio is the use of Agilent Jetstream ionization, or AJS for short, as the default ion source configuration for users. We chose this because it provides users a brighter ion response due to the application of superheated nitrogen sheath gas and a nozzle voltage controller to have greater influence over the spray shape and the ion sampling regions. To really demonstrate the effect of superheated nitrogen gas on ion sampling, the image shown is running in standard electrospray conditions. After sheath gas superheating is enabled, the spray cone is much more focused and less visible, implying that more liquid droplets have been desolvated, bringing more ions into the mass spectrometer. Because more ions have been desolvated into the gas phase, greater ion flux is observed, resulting in greater analytical sensitivity and allowing customers to achieve lower limits of detection than standard ESI. However, regardless of the applications users wish to perform, we have a nice portfolio of available ion sources to utilize, based on the electrospray mechanism, or based on the APCI mechanism, in addition to the ion source interfaces for capillary electrophoresis or nanoflow HPLC. As we go into the actual guts of the instrument, one surprising thing to note is that the 6470B and the 6495C triple quadruple LCMS systems are built upon a common ion optics platform. This means that they share many performance characteristics to one another, especially in terms of signal stability, robustness, versatility, for different routine and research applications, and the technical capacity to get the job done. On this common ion optics platform, it's comprised of an octupole ion guide to allow transmission of ions over a wide effective M/Z range, an RF-only brew breaker pre-filter for the pre-focusing of ions into the quad, defeating the fringe field effects for higher analytical sensitivity. Of course, we utilize hyperbolic quads for efficient mass selection. They're also heated to maintain signal stability and prevent mass calibration errors. A hexapole collision cell, which also has an extended mass transmission range, but is curved and tapered so that we can prevent neutrals that are produced after collision from hitting the detector, while the taper helps refocus and collimate the ions for transmission into MS2. And lastly, an advanced detector system comprised of an adjustable, up to 20 kV, high-energy dynode system used to launch particles towards an electron multiplier horn. Over the past decade, since we've launched the first instrument models on this platform, we've iterated and improved year over year to provide the most reliable and sensitive LC-MS systems to our users. One of the nice things we found with this ion optics platform on the 6470B and 6495C is that users really appreciate the ability to analyze ions over an extremely wide M/Z range. Not only could users analyze and quantitate the bread and butter small molecules like pesticides, metabolites, pharmaceuticals, it's also possible to analyze larger ions such as peptides, oligonucleotides, carbohydrates, and synthetic polymers. The example shown here is just a demonstration of our ESIL calibration ions throughout the mass range, showing good performance throughout. Additionally, we always talk about the robustness and stability of this ion optics rail for these instruments, so here's some data to prove it. This was carried out using our rapid-fire system for sample delivery, and in this case, we've carried out 10,000 injections of pharmaceuticals spiked into pork plasma. This is done non-stop with no cleaning or tuning. When plotting the chromatographic peak ratios with their isotopically labeled standards, signal percent RSDs were less than 10%. This demonstration was carried out on the 6470A version of this model. However, the ion optics rail was retained with what we have today. So between the 6470 and the 6495, what's different? I mentioned earlier that the ion optics rail is shared between these two instruments, but notice the protruding area after the ion source. This houses what's called, and what we refer to as, the eye funnel, made up of two stacked ring ion guides. This allows users to excel in the most rigorous analytical conditions by achieving incredibly low limits of detection and instrument detection limits. This allows users to obtain high measurement precision at standard concentrations for greater detection confidence. This instrument is able to achieve the lowest levels of analytical sensitivity because we've extensively considered what happens as ions are introduced into the mass spectrometer. As droplets get desolvated, ions enter the instrument as a diffuse cloud influenced by electronic forces. To capture as much of the ion cloud as possible, the first stage of the ion funnel captures stray ions and collimates it back into the beam. The second stage further focuses the ion beam for transfer to the ion guide, and the end result is a greater number of ions flowing into the instrument. As a demonstration, consider a standard checkout experiment, 1 picogram of reserpine on column. The chromatographic peak shape is very nice, signal is confidently detected, but it essentially tells us nothing of the analytical sensitivity of the instrument because we can't see the noise. Instead, 1 femtogram of reserpine column is injected, which is 1,000 times less, giving us a better sense of the baseline noise and the rough magnitude of concentration levels users can expect to successfully detect without issue. One interesting thing is that to guarantee the analytical sensitivity and performance of this instrument, this exact experiment is demonstrated at every customer installation, where we expect to observe and measure an instrument detection limit value of less than 0.65 femtograms of reserpine on column, and this is specified as the best IDL specification on the market. The last triple quadruple LCMS hardware platform in our portfolio is the Ultivo triple quadruple LCMS, which was a disruptive product to the industry. Many of the hardware components were re-engineered to ensure that it had a small form factor. However, despite its size, the performance of this instrument is uncompromising, as it was intended to be a continuation of the legacy workhorse instrument, the 6460, with the same specifications, instrument sensitivity, and robustness, with any improvements that we can fit in. Horizontally, the Ultivo is roughly 3 times smaller than the 6460, giving users access to precious lab space for other tasks like sample staging or for even fitting more instruments into a smaller space. Additionally, the Ultivo was designed to be stackable by seamlessly incorporating into the HPLC stack at the base. And when incorporated with the right furniture, such as the FlexBench MS, the Ultivo is completely unified as a mobile platform. This allows some users to bring in and out a mass spectrometer whenever it's needed. Oftentimes, people equate small to less sensitive or incapable, so in order to preserve instrument sensitivity, many of the traditional mass spectrometer components had to be reconsidered and redesigned to operate in a small form factor. The Ultivo was such an incredible advancement forward for the development of this small form factor due to the large number of inventions and innovations made. Routine maintenance had to be simple, so the VacShield was first developed on this platform. A traditional octuple ion guide is too large, so instead the cyclone ion guide, a twisted and tapered hexadodecapole, was invented. The traditional 2 cm RF-only Brubaker pre-filters are too large, so instead 1 mm DC-only virtual pre- and post-filters were developed instead. The quadrupoles had to be shrunk, which is a major manufacturing challenge on its own. And lastly, the vortex collision cell was based on the cyclone ion guide design to maximize ion recollection after fragmentation and to prevent sensitivity loss within this small form factor. With many of these hardware innovations included on this platform, we were recognized in 2018 as award winners by IBO and Scientist Choice. As we do so with all our instruments, a robustness test was carried out on Ultivo as well. In this case, 10,000 non-stop, uninterrupted injections of pesticides spiked in black tea were measured. Surprisingly, despite how dirty the original sample was and how dirty the source got, peak area percent RSD remained less than 10%, demonstrating the instrument's incredible robustness for routine analysis samples. And as we pushed the instrument hardware boundaries, the instrument control software did as well. Incorporated with Ultivo were software features designed to address many of the pains users experienced when interfacing with the instrument. Things like knowing when to carry out instrument maintenance, routine or extensive, or having the instrument check-tuned or auto-tuned and ready to go once users come into the lab. Additionally, data analysis should be comprehensive, but not complicated or complex. Throughout our whole portfolio, with our data analysis platform, we've allowed users to hone in on the features that matter to them the most, streamlining their workflows to be as efficient as possible. And lastly, even with only 3 triple quadruple LCMS products within our portfolio, the amount of hardware innovations, features, and functions is a lot to take in. Instead, you can rely on Agilent to be a partner for your success, as we also aid in solving user problems through our end-to-end comprehensive workflow solutions. These kits contain all the necessary materials needed for a successful workflow. For example, this comprehensive vet drug workflow solution we've just launched contains everything users need to get started in vet drug analysis on a 6470B or a 6495C for the analysis of over 200 compounds. Before I wrap up, I just want to point out the guiding principles and the approach that we take when designing our mass spectrometers. We don't want the mass spectrometer to be just a box, but rather a component for users' overall laboratory success. So as we move into the future, we're always keeping the user's needs in mind. So as I close, I just want to wrap up and remind you that Agilent has a rounded 3-product triple quadruple LCMS portfolio, with the latest launch, this ASMS Reboot for the 6470B. We strive to provide users with instruments that are not only sensitive, but extremely robust as well. The software we provide aims to be comprehensive, but not complicated or complex. This era requires software to be matched with their hardware for better instrument intelligence and monitoring. Sometimes, focusing just on instrumentation is a lot to take in on its own, not considering sample prep, method development, consumable choice, etc. So we provide LCMS-oriented comprehensive workflow solutions, such as the vet drug analysis solution. And lastly, we're always sticking our ear to the ground regarding user feedback because we want future development to be driven by addressing real user pain points and needs, and keeping up with their ever-evolving and changing requirements. With that, I'd like to thank you for listening, and if you're interested in any of these solutions, please check out agilent.com.